Okay, looking at 4.8 is going to be our first introduction into what are called complex numbers. Okay, I've kind of hinted at complex numbers before over the last week, or maybe even as we went into the beginning of this chapter. But we're talking about complex numbers, and a complex number uses something called the imaginary unit I. Before today, everything about your math has dealt with real numbers. Okay, anytime we talk about what type of number is it, everything falls into the real number system. Okay, whether it's a fraction, whether it's a positive, a negative, a square root, everything we've done has fallen into real numbers. Today, we're going to start talking about imaginary numbers, which are represented by I. Okay, you won't often, if at all, ever see me use I as a variable. You know, we're randomly picking variables. I don't use I because I in the math world represents the imaginary number, I. Now, here's what you've got to know, guys. The two basic ideas of complex numbers come from two facts. I'm going to do these out of order. First of all, I is the square root of a negative 1. Okay, up until today, when we try and take the square root of a negative number, what do you tell me? You can't do it, right? And what it comes down to is you can't do it in the real numbers, okay? The square root of a negative number is not a real number. It's what we call an imaginary number. If you try and do the square root of a negative number on your calculator, you get some kind of error, depending on the calculator, right? So, square root of negative 1 represents the imaginary unit. Now, the other piece of information that will be helpful to know is that then that makes I squared negative 1. Because think about this. If I is the square root of negative 1, what happens? Well, when you square I, you're going to get I squared. What happens when you square a square root? When you square a square root, you get, well, whatever's under the radical. And what's under the radical here is a negative 1. So those are going to be the two pieces of information we're going to work with as we go forward in this lesson. Now, so for example, from this idea, we can square root negative numbers. If you put square root of negative 5 in your calculator, you get an error, right? Now, if you put square root of 5 in your calculator, you get a decimal, because the square root of 5 is irrational. What we can do about this, though, is we can kind of break this up in that anytime I see a negative under my square root, I break it into a negative 1 times the number. So negative 1 times what is 5, and that's negative 1 times 5 is negative 5, correct?
Yeah.
And what do we know? And I guess I should have written this. I'll write it. So this is the same as saying square root of negative 1 times square root of 5. But what did we just define square root of negative 1 to be? Square root of negative 1 is I. So the idea then is that this square root of negative 1, because it's I, can be rewritten as I times the square root of 5. So what I'm going to try and get you guys in the habit of doing is anytime you see a negative sign under a square root, we're going to pull that negative sign outside, and it becomes an I when you put it outside of the square root. That's what we're going to be working with these I values. Okay? Now, let's go ahead and look at some example 1. And example 1 says to simplify each of the following. Now, we haven't simplified radicals yet this year, right?
Right.
Other than we did a little bit with quadratic formula. Okay, so there's a chapter second semester, I don't remember which chapter it is, where we simplify square roots. And that will be the big thing. We're not going to do big stuff with these simplifying square roots, but we're going to just do some of the basics, okay? So as we look at A, and we talk about how to simplify the square root of negative 18. The first thing you should see, Big and bold. What do you see under that square root?
Negative.
A negative. So I'm going to pull that negative out as a, okay, as an I. For the moment, I'm just going to say square root of negative 1. But yes, when we go down here, it is going to be I. Now, 18. Can I take the square root of 18 as is? No. No. So we have two options at that point. Either 18 stays under the square root sign as is, or there's perfect squares within 18. So what you always need to ask yourself, and we did this once last week. The one we did last week was 28, and 28 became 4 times 7 because 4 was a perfect square. So you need to ask yourself, are there any factors within 18 that are perfect squares? Kylie?
9.
What do we know about 9?
Square root of 3.
Square root of 9 is 3. And what do we know about 18? 18 is 9 times 2. And so because there is a perfect square within 18, I'm going to break that 18 up. And so 18, I broke up to be 9 times 2. And we already had the square root of negative 1 out front. So the square root of negative 1 becomes I. What do we know about the square root of 9? It's 3, yes? Because 3 times 3 is 9. So the square root of 9 I can rewrite as 3. What do you know about the square root of 2? It's a decimal. So what am I going to leave it as? Square root of 2. Now, all I do here is just put this back in a good form. And the good form that we usually use here is, first of all, whole numbers like 3. They stay in front of the radical. We're going to do the same thing like with I. But think more of I. It's not a variable, but we kind of act like it's a variable. And so when I write this answer, I'm going to write 3I times the square root of 2. Okay? Math Excel might have some flexibility with how you enter that answer, but that's probably your best form. And I'm honestly not sure what flexibility Math Excel will have, so. But they might have some. I can't guarantee it. Okay, let's try B. What's the first thing you have to notice on B? There is a negative. So as I separate this into pieces, one of my pieces is square root of negative 1. 12. Can I take the square root of 12? I get a decimal if I do the square root of 12. Okay, next question. We have to figure out, do we get to leave it as 12? Or is there a perfect square within 12? What does 12 divide by that's important? 4, right? Okay. And when we talk perfect squares, guys, 4 is a perfect square because I can take the square root. 9 is a perfect square because I can take the square root. 16 is a perfect square. I can take the square root. 25 is a perfect square. 30, there's a whole list of them, right? Okay, so 12 can be rewritten as square root of 4 times square root of 3. Did I change the value of this problem? Negative 1 times 4 times 3 is still negative 12. So I haven't changed the value of the problem. I just rewrote the pieces. Okay. What's the square root of negative 1? I. What's the square root of 4? 2. What's the square root of 3? Square root of 3 or some crazy decimal. How am I going to write my final answer? 2I square root of 3. Okay. 2 more. And that will end class, I guess, today. Okay, square root of negative 25. Again, I'm going to ask the same questions every time because I like to try and train, your brain's thinking what questions I need to ask. What's the first thing you see?
Negative.
A negative. So I'm going to make one of my factors as the square root of negative 1. What do you know about the square root of 25?
It's perfect. 5.
It's perfect square itself, isn't it? So for this line, I'm just going to leave it as square root of 25. I don't need to worry about looking for perfect squares because it is a perfect square. What's the square root of negative 1? I. What's the square root of 25? 5. What's I times 5, do you think?
5i.
5i is what I would write. Last one. Square root of negative 7. What do you see first?
Negative. Square root.
A negative. So I'm going to pull out a square root of negative 1. Square root of 7. Is it a perfect square?
No.
No. Okay. What perfect square are within 7?
It's prime number.
What does prime number mean, Noah?
You can't divide. You can't multiply anything to get to that number.
Okay. A prime number has exactly 2 factors. 1
And itself.
and itself. Sound familiar?
Yeah.
Good random word for me to throw in as a review here. So 1 times 7 is the only way I can get 7. Or either of the, 7's 7.
Yeah.
It's not a perfect square. Technically, we could say 1's a perfect square, but does that change anything?
No.
No. So square root of 7 is going to stay square root of 7. What's the square root of negative 1 then? I. What's the square root of 7?
Square root is 7.
Square root of 7. I'm going to write this answer as I.
7.
Square root of 7. Okay. So that is your introduction to imaginary numbers. It's the square root of negative 1. Yes?
Doesn't have a perfect square or anything, is it just the opposite? Because
Okay, guys, quiet.
so because that will get the square root of negative 7, but there's not perfect square or anything on it. Will it always be like the opposite?
It's not the opposite. Well, in the fact that it's once we put the I out front, yeah, it's just then positive 7.
Okay.
Okay, tomorrow we may come back and do some more of these notes to kind of introduce them some more, and then I'll finish up maybe some note, Monday, finish up anything we need to in some work time. Again, I may save the rest of this lesson for Monday. I'm undecided with what I'm doing, okay? You'll find out tomorrow. Have a good day, guys. It will be. It'll be a surprise. We love